written in syllabus in different way, that is called acid and base. Okay, or it can be mentioned in the book in differently, right? The chapter name, but the things are same, materials, the topic inside the material is same. Okay, what we'll discuss, can you see the screen?
Yes, sir.
Okay, you have already studied this few topic we'll discuss in this chapter. For example, the Arrhenius concept of acid and base, right? Have you studied in HSC?
Yes, sir.
Who can remember what is Arrhenius concept of acid and base?
Sir.
Anyone?
Sir. So I can say, sir.
I couldn't hear you properly actually.
Sir, can you hear me, sir?
Now I can hear you, right?
Oh, sir, everything's written here. According to the Arrhenius concept, any compound donating H plus will be acid, and donating OH minus will be base.
Is it complete?
In
version?
water.
In water.
In
Okay.
aqueous solution, sir.
In aqueous solution or water? What is the difference between aqueous solution and water? What is the difference between water and aqueous solution?
So when we say aqueous solution, it means water is the solvent, specifying the solvent.
Aqueous solution means there is a presence of water, right, in the solution, isn't it?
Yes, sir.
Okay, here HCl is a acid according to Arrhenius concept. How you can say that one is acid, HCl?
Donating protons in water.
It is donating a proton in the aqueous solution. Okay, you have to mention the aqueous solution. Whenever it donates the proton, that not means that according to Arrhenius, that not means that that is a acid. Rather, it should be in aqueous solution. The condition is two. First, it has to donate the hydrogen ion, right? And second condition is it should be in the aqueous solution, isn't it?
Yes, sir.
Very good. How about base?
Sir, here sodium hydroxide donating one hydroxyl ion in the aqueous solution.
Right, very good. So it has some limitation, right? From the condition when we discuss the definitions, there actually you can understand that what is the limitation of this theory. First limitation is free hydrogen ion it is discussing, right? And hydroxide ion, it is saying about the free hydrogen ion and hydroxide ion, but that normally do not exist in water in free state. Have you understood?
Yes, sir.
Rather, they form a hydronium ion in the water or aqueous solution, in the water or aqueous solution. So in Arrhenius concept, they are clearly mentioned about the free hydrogen ion or hydroxide ion should be donated or should be accepted, right? So should be donated by the acid and base respectively, but practically these two form hydronium ion in the water or in any aqueous solution, isn't it? So this is first limitation. Second limitation. Another condition was that reaction or that donation of hydrogen or donation of oxygen hydroxide ion should be in the water. That is actually kind of limitation, right? It is limiting the area, right? It is limiting the level, so it is another limitation. And some bases later on, actually it is discovered that some compound which has some basic property but that does not have hydroxide ion. Okay, this hydroxide ion doesn't have in those basic property compounds. So this is also another limitation we can say. Clear?
Yes, sir.
Sir.
Okay, next one is Bronsted-Lowry concept. Bronsted-Lowry concept, who can tell?
Sir, according to Bronsted-Lowry, acid is which can donate proton and base is which can accept proton.
Sir, according to Bronsted-Lowry concept, the molecule that provide hydrogen ion or proton is
Acid.
acid, sir.
Okay. Donation of hydrogen will be done by acid or base?
Acid.
Acid, sir.
Acid. And accepting the hydrogen ion is a
Base, sir.
base. Very good. Okay, so if we just try to differentiate between the ARRHENIUS concept and Bronsted-Lowry concept, Bronsted-Lowry concept is actually broadening the idea, right? The ARRHENIUS concept was limiting the acid base definition in the hydrogen ion and hydroxide ion, right? Rather, in the whereas in the Bronsted-Lowry concept, here the concept is only limiting to hydrogen. That means actually it is excluding hydroxide ion, isn't it, from the definition? So it is actually broadening the concept. This is one thing. Another thing is there is nowhere mentioned about the aqueous solution, isn't it, in the Bronsted-Lowry concept? So it is also in another way, it is also broadening the concept that not only the aqueous solution, if it can donate the hydrogen ion or it can accept the hydrogen ion, then it can be acid or base respectively, isn't it?
Yes, sir.
So here, which one is acid and which one is base according to Bronsted-Lowry concept?
Sir, HCl is acid and Cl minus is base, sir.
Okay.
Conjugated base.
Conjugated will come with this term later on. So as you already told, there is conjugated base of HCl and this is conjugated acid of the water molecule, right? Okay, so now
Yes, sir.
what we have already discussed about the Bronsted-Lowry concept and ARRHENIUS concept, so we can now compare to each other, right? And we already discussed Bronsted-Lowry concept is much wider, right? Much
Yes,
wider in scope because Bronsted-Lowry has exclude the hydroxide ion, right? Exclude the hydroxide ion in water. So this is one of the widening process in the concept. Second one is not limited to the aqueous solution, as you already told, right? The Bronsted-Lowry concept is not limited to aqueous solution. And third one is the release of hydroxide ion is not necessary to be qualified as a base. Rather, if it can accept the hydrogen proton, hydrogen ion, that will be a base, right? So according to
Yes, sir.
Bronsted-Lowry, base NH3 doesn't have any hydroxide ion, right? Still it is a base because it can accept a proton. I hope it's clear, right?
Yes,
Yes,
sir.
sir.
Okay, so next, Lewis theory. Please, anyone, can you be volunteer?
Sir, substance that provide lone pair to another substance is called Lewis base, sir.
Okay. So here the concept is related to lone pair, right? Or electron pair, we can say. Electron pair acceptor and electron pair donor, right? Acid is a electron pair acceptor and a base is a electron pair donor according to Lewis concept, right? So
Yes, sir.
acid will be electron pair acceptor, right? And base will be electron pair donor. So Lewis base, according to Lewis concept, ammonia is a base. According to Bronsted-Lowry also, the ammonia compound is a base, right? So it can be a question that how can you explain that
Yes, sir.
NS3 is a Bronsted-Lowry base and Lewis base, Bronsted-Lowry and Lewis base, Bronsted-Lowry base as well as a Lewis base, right? So you can explain that NS3 is a can accept a proton, so that's why that can be called as Bronsted-Lowry base, right? And according
Base, sir.
to Lewis base, because a base donates a pair of electron and NH3 can donate a pair of electron to another compound or another molecule or another ion. So according to that Lewis concept, NH3 is also a base or Lewis base. Okay, so some of you already told about the conjugate acid base pair. What is conjugate acid base pair?
The acid gives a proton, becomes a base, and we can call it the conjugate base of the acid.
So acid is giving up a hydrogen ion, right? Proton. And it is accepted by another ion or another molecule, right? So
Yes, sir.
the ion or the compound which is actually donating the proton, that is conjugate acid, right?
Yes, sir.
And the molecule or ion which accepting the proton, that is called conjugate
Base, sir.
base. Okay, so weak acid form a stronger base, right? Or weak acid or any acid form a base. Any base form a acid during the conjugate acid base pair reaction. Okay, this is not reaction, rather it is actually forming a conjugate acid and forming a conjugate base, but in the aqueous solution basically. Okay, or in any solution, okay. So another topic is pH. What is pH?
Power of hydrogen.
Power of hydrogen. Anything
So
else?
minus like log of concentration of hydrogen plus ion.
Minus concentration
Negative
of
logarithm of hydrogen.
negative
Negative
logarithm.
logarithm of molar concentration of hydrogen ion.
Negative logarithm of molar concentration of hydrogen ion. Very good. So what does mean actually with this logarithm and molar concentration? What is the significance of this one?
We can find it is acid or base through pH.
As you already told, this is the power of the acidity or basicity we can understand, right? From the pH. So if the concentration is higher, if the concentration of proton is higher, then acidic power will be higher, right? That means actually acidic power is higher, right? How about POH? Can you tell?
So negative logarithm of molar concentration of hydroxide ion.
Okay. Negative
Also, we can
logarithm
get
of
it
molar concentration
by
of hydrogen ion.
subtracting
And what is
from
the significance of POH?
the
To
power of
identify
hydroxide ion.
the base power of molecule or a
Right.
substance.
Okay, so you already studied this equation as well, right? That POH and
Yes,
pH will be in total it's 14.00, right?
Yes, sir.
Okay. So if we come from the POH, so we can write minus log OH, and from the pKw, we know that minus log of KW. The dissociation of water, from the dissociation of water we can get this one, and then KW will be this one, dissociation of water, right? These two will
Yes, sir.
be ion, and then if we use the log, then we will get this one, and ultimately if we use the minus log KW means that will be written as PKW, right? And PKW will be this one, and then ultimately you will get this equation. And so you can explain that the total of pH and POH will be equal to 14, right?
Yes,
right.
sir.
Okay. Another one is common ion effect. Another topic is common ion effect. Do you know what is common ion effect?
That the reduction of the degree of dissociation of a salt by the addition of a common ion is called the common ion effect.
Okay. So basically what happens due to the common ion effect? Reduction will be, dissociation will be reducted, right?
Yes, sir.
The solubility reduces as a result, I think.
Solubility will be decreased, right? The dissociation will be reduced, isn't it? So the presence of any ion in a aqueous solution and or any other solution, due to the presence of any ion, the the due to the higher concentration of any ion, the dissociation will be hampered, right?
Reduced.
Dissociation will be hampered, and that's how the dissociation will be reduced. For example, if we just give on practical example, you are dissociating the sugar in water, right? So in a small amount of water, then what happens in the very beginning? Uh, the sugar will be dissociated readily, right? Immediately. But when the concentration will be increased, sugar will be ionized in the water, right? So there will be more concentration of ions, and the more will be increased the concentration of ion, that the dissociation of sugar, right, or solubility of the sugar will be decreased gradually, isn't it?
Yes, sir.
Due to that, due to the common ion effect actually. Okay, same goes for the dissociation or the solution of, when you prepare solution of sodium chloride with water, right? So this happens due to the presence of ion, and
Common
that
ion.
actually, right, common ion, and that reduced the dissociation, and that is called actually common ion effect. Okay, there is another example, this one. So due to the presence of any ion, uh, this kind of salt will be dissociate, uh, the dissociation will be decreased. Okay, another one, another topic is buffer solution. What is buffer solution?
A buffer solution is a solution which resists the change of pH if we add H proton or hydroxyl in that solution.
Sorry, a weak acid or a weak base and its salt is makes a buffer solution, sir.
Okay,
Where
very good.
if we add hydrogen ion or hydroxide ion, the pH will be no change.
Yes, right. Basically, a weak acid and its salt, or a weak base and its salt will prepare the buffer solution, isn't it?
Yes, sir.
And when you add a small amount of, not any amount, right? Very small amount of
Yes,
acid or base, then it will, the change in the pH in of that solution will be negligible. That means actually it will have some change, but that will be negligible change. It's not constant. It cannot. It's not that the pH will not be changed at all. Rather, the change will be very negligible one. Okay, so that solution which can resist to change its pH to the big margin, that is called actually buffer solution. So we can say addition of a small amount of acid and base in a buffer solution resist the change in pH, right? So
Yes,
how
sir.
this buffer solution actually resist to change its pH? Can you explain from this mechanism?
So when we when we are small amount of hydrogen ion, this hydrogen ion will react with sir the ion of which comes from salt, like
Yes,
here
right.
ethanoate ion, and
Right.
will reform ethanoic acid.
Right.
And
So
if we
there
add
is a
some hydroxide ion, it will
yes.
react with hydrogen ion and
Okay. We understand that addition of hydroxide ion, when addition of hydroxide ion happening, that will react with hydrogen and it will produce water. And you know that water is
Neutral.
pH
Neutral, sir.
7, neutral, right? So pH will not be changed. We can understand easily, right? But how about this one? Addition of hydrogen, that means addition of any acid, then it will react with this one, negative ion of that salt, and then it will prepare another acid. Then if there is a preparation of more acid, will not be changed in pH. What do you think?
Yes, sir. If we add hydrogen on more, then it will maybe change, sir.
For example, we are not using more, rather we are adding only one mole of hydrogen ion. So it will produce another acid. So production of this acetic acid will not increase the pH in the buffer solution. What do you think? There is
No,
a
sir.
production of acid.
Sir, it doesn't dissociate much, sir, because
Yes,
it's a
very
weak
good.
acid.
Yeah. So that is this actually has the tendency to partially dissociate, right? But if the environment is not favorable, then it will dissociate less, more lesser, isn't it? So the
Yes,
in
sir.
the assay in the buffer solution, there is already presence of acid, right? So due to the presence of acidic part, the newly produced this acetic acid will not be dissociate much. That means that will be mostly unionized. If it is unionized, that means that it cannot show its acidic property. If it cannot show the acidic property, that means actually it will not give or it will not donate hydrogen ion, and that's how pH will not also be increased. Is it clear?
Yes, sir.
Now, if we discuss about the basic part of the buffer solution, basic buffer solution. Again, similar thing, addition of hydrogen in case of basic buffer solution. This is basic buffer solution. Uh, it is reacting with hydroxide ion and it will forming water. It is common that water has neutral pH, so it will not increase the pH in the buffer solution, right? So how about this one?
Yes, sir.
How can you explain the production
The
of a
same, sir.
base
Ammonium
is actually
hydroxide will
happening,
not
right?
dissociate much as they are.
Right.
Yes,
Right.
sir.
Continue. Undissociated, right?
Sir, these are newly produced ammonium hydroxide will not dissociate much, sir,
Right.
because of previous ammonium hydroxide, which is
Right.
dissociated
Right. So that will
already.
be approximately constant. It's not completely constant, rather the change will be minimum. The change will be very negligible. That's why the pH will be approximately constant. Okay.
Yes, sir.
Yes. Next topic is Henderson-Hasselbalch equation. Have you studied this one in HSC?
Yes, sir.
Yes.
All of you have studied, and this one is a very simple one. Dissociation of weak acid. From there we can calculate the Henderson-Hasselbalch equation for a weak acid, right? This is called Henderson-Hasselbalch equation for Henderson
We
equation, also called, we can also say,
the
for a
basic
weak
buffer
acid,
solution.
right? For a acidic buffer solution, right?
Acidic buffer solution.
Right, very good. Acidic buffer solution. And we, in the similar way, we can derive the basic
Calculate
buffer solution.
pH.
We have not actually, we have not shown you the derivation for this one. Can you derive, if we give you to derive this one?
Yes, sir. Inshallah.
Because it will be the similar fashion, right? Like the acidic one, you have to take one base here, right? And according to, there will be dissociation of base, and then you will get the base here and salt here, right? And it will be Kb, right? That time.
Yes, sir.
And then likewise there will be OH here, right? OH,
Yes, sir.
POH, and this will be Kb, log Kb,
PKB.
PKB, right? And this will be base, right? So likewise it will be completely formation of POH, and it will be PKB, and this will be base, isn't it?
Yes,
So
sir. Yes, sir.
just you have to transform this equation from acidic part to basic part. Okay, this all. So this is very simple, common equation, and also you have studied in HSC. I hope it will not be any problem to study this one, right? And last topic is significance of Henderson-Hasselbalch equation. From Henderson equation, what we can understand?
So we can calculate the concentration pH value of any weak acid or weak base in a buffer solution, which is
from K value, right?
Yes, sir. K or Kb, sir.
Right. And as you already told, we can also measure the pH, right?
Yes, sir.
And we can use the desired pH for any purpose by using this equation also. So these three are the actually basic significance of Henderson equation. Okay, these all topics are actually studied by you in HSC, and hopefully these are very common basic part of acid base solution. And this chapter is also, I have made concised one, so that you don't have any problem for understanding. Still, if you have anything to discuss regarding this topic, regarding this chapter. Anything?
No, sir.
Okay. Okay, so I hope the syllabus is done. This is the last class before the last one, actually. Next week there will be another class. Hopefully we can review our full syllabus if you need, and then we will try to clarify if there is any question, query about the exam system or any other thing. But still we have some more time to finish this class. So we can have some question from you and we can discuss about the exams and other thing. As you already asked about the Viva, maybe, or is it the question for Viva? Some of you have asked already.
Yes, sir.
What kind of Viva you want to know, or what is actually question? What is the specific question? What is specific question? Can you ask the question again?
Sir, question type and when the Viva will be held.
When or how? What do you think? What do you say?
Sir, after the exam, sir.
Okay, Viva pattern for Viva syllabus is full syllabus.
Yes, sir.
Any instructor, whoever take the Viva, if it is me or Professor Abdul Jabbar sir, whoever take the Viva, the syllabus will be full. That means section A and B. Have you understood?
Yes, sir.
And there is nothing from the syllabus will be skipped in the Viva. So full syllabus will be covered, completely full syllabus. The question may come or may ask to you from anywhere, from any part of the topic. Mostly it will be will be stick to the materials, whatever materials uploaded in Google Classroom. We'll try to stick there, but sometimes related matters may come along with the proceedings of Viva. Have you understood?
Yes, sir.
Is it clear? Okay.
Yes, sir.
What is the date of the exam? It's 18, right? Of your exam, chemistry.
Sir, chemistry final exam.
Right.
Sir, it is given, the date is given on 26 August, sir.
26 August. That means it will be the first one.
Sir, that is the last one, sir.
Oh, last one means August, not July. Understood. Is there any gap between this exam? Before this
Sir,
exam?
yes, sir. Sir, we have one exam on 24, and after that, the chemistry exam on 26.
One day only.
Sir, yes, sir. Last 3 exam we have got very less gap, sir. Only like we have one exam on 22, then 24 and 26, sir. The exam date is given like this, sir.
Okay. Anyway, I hope you can manage somehow. Regarding the Viva, is it your exam on the afternoon or in the morning?
Sir, the exam is in the morning, sir.
In the morning, right? Okay. So
recording stopped.
There is a possibility that the Viva may be taken on the exam day immediately after the exam. Maybe you will be given 1 hour or half an hour to be refreshed, and then we may start the Viva, or it may be at the afternoon or at the next day, on the next day. Have you understood?
Yes, sir.
So the things and how the viva will be taken, how you will be will the viva will be groupized or single, whatever the case, you will come to know later on. Okay.
Yes, sir.
Now, and if there is any other question.
Sir, before the chemistry final exam, sir, we have very less time, only 1 day gap, sir. And
Right.
again, we have two section, like section alpha and section bravo, sir. So, sir, before the final exam, if you provide us some bit of suggestions, sir, about the question pattern and some suggestions, then it will be helpful for us, sir.
The full all materials is the suggestion. Okay. The materials uploaded, that is concise one from my side, and there is no skip, no materials to be skipped.
Sir, if there is anything like we need to emphasize more, these are the
If you go through the videos of my class, I think you can understand. You can get some clue. Okay, the syllabus is not that much tough. It is quite easier one. So, and then mostly you have studied in HSC. And the most part is we have actually reviewed, and some only very few parts are new part for you. So new chapter, new topic for you. So I hope that this syllabus will not be very difficult to understand. Will be very difficult to understand. So you you should not skip any part of the syllabus, I hope, for final exam as well as in the for the viva. And the question pattern is mixed one. So the chapter wise is not, question is not given in chapter wise, rather it is mixed chapter. Okay. A few question come from one chapter, from another chapter, and the whole set of question, for one set of question it is mixed one. So you cannot skip any chapter as well. Okay. And for suggestion, if I give you some suggestion for emphasize, then I have to tell the question only, no other option. So it is not ethical to give the question, right? As I understood, as I believe, the syllabus is very concise on. Okay. The things will not be difficult for you. Study first, read first, try to understand, and then study. I hope that will be enough for you. And you will get maybe the some preparatory leave, 15 days, right?
Yes, sir.
yes, sir.
Okay, so use that one. All materials is my suggestion. If you go through the materials, I hope you will get at least average marks, 2 good marks. If you go to the book, if you review the book, then you will get very good marks.
Sir, about the viva, sir, how much time will each student will get for answering, and how many questions we might face?
It is depending on the situation. We'll inform you later on.
Okay, sir. Thank you, sir.
Okay, so time is almost up. Let's conclude the session here. We'll have another class hopefully next week.